Hey everyone, this is number 5C. We are still looking at the 2018 FRQ, no calculator section. And the sum of this question, all it gives us is a function f of x equals e to the x times cosine of x. Letter C asks for the absolute minimum value of f on the interval from 0 to 2 pi and to justify your answer. So the first question is, where would you find an absolute minimum? And you could have an absolute minimum at critical points or endpoints. We are also going to be making a chart for this question to organize all this information. Do you remember what that chart is called? It is the candidates test or a chart of candidates. And so let's enter the easy ones first. That is going to be the endpoints. So an absolute min can happen at an endpoint. So we're going to consider 0 as a possibility or a candidate and 2 pi as a candidate as well. So that takes care of our endpoints, done with those. And then we have to look for our critical points. So think about the definition of a critical point. That is where the derivative is equal to 0. So we had previously taken the derivative in, I think it was part B, and that was with the product rule. So I will not go through those steps again. Just for the sake of time, we did that already. Our derivative was e to the x cosine of x minus e to the x sine of x. So we're looking for our critical point where the derivative is 0, and we have the derivative written there. So we want to know, where is that derivative equal to 0? And we do not have a calculator. So this is a pretty interesting question. First, do you see something that we can factor out? And we could factor out e to the x because both terms have e to the x. And that would leave you with e to the x times the quantity cosine of x minus sine of x. And this is similar to when you have factors and you're trying to solve. I'm just making up this example on the side, and you set your factors to 0 to solve it, right? So the next step in this example would be setting your factors to 0 and solving it. So we're going to do the same thing here. We're going to set the first factor to 0 and the second factor to 0. Okay, and then we're going to solve those. So e to the x is actually never going to be 0. E is around 2.7. And so even if we raise e, so to a positive power, 2.7 squared, to a negative power, you get 1 over e squared, to the 0 power, you get 1. You're never going to get a 0. We did a lot of that work in junior year, saying that a positive number raised to a power is never going to be 0. However, the other factor, cosine of x minus sine of x equals 0, that will happen. I'm going to move the sine of x over. And basically, we're looking for where is the cosine equal to the sine. So this moves us to the unit circle. And in the unit circle, the cosine is the x value and the sine is the y value. So you're thinking about, where is the x value the same as the y value? So here's an example. The coordinates here are 1, 0. So that would not be the answer or the location of where the cosine of x is equal to sine of x, because 1 is not equal to 0. So there are actually 2 places. The first one is going to be at that 45-degree angle, that middle branch of pi over 4, because the coordinates there are root 2 over 2 and root 2 over 2. So pi over 4 would be the first place on the unit circle where the cosine and the sine are equal to each other, or the x value and the y value are equal. So pi over 4 is one solution, and the other one is going to be over here. It's not going to be on this middle branch because you have negative root 2 over 2 and positive root 2 over 2. So that middle branch, the x and the y values are not equal. But when you go to the middle branch of quadrant 3, the coordinates are -√2/2 and -√2/2. The AP test doesn't often have us going into that third quadrant with the unit circle, so I think this is particularly challenging for that reason. And the juniors are doing this right now to figure out what's the radian measure there. So if you are going around by fours, how we phrase that, right, to hit all those middle branches, you have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and this would be 5 pi over 4. Right? When you split into 45 degrees, you have those 4 pizza slices, so you're going around the circle by fours. So 5 pi over 4 is your second answer. That's the other place where the cosine of x is equal to the sine of x, or the x value is equal to the y value. They're both -√2/2. One reason I knew to keep going around the unit circle was because the question wanted me to look from 0 to 2 pi. So it wanted me to make a full revolution around the unit circle and to find the places where the cosine and sine are equal. So we have to add, let me just move this up a tiny bit. We have to add those points, pi over 4 and 5 pi over 4, to our candidates test. So we have our endpoints of 0 and 2 pi. We got our critical points of pi over 4 and 5 pi over 4. And then the very last thing, and I'm going to erase this just so I have some space, is we have to figure out what is the output. What are the outputs at those points? Because we're looking for the actual minimum. What is find the absolute minimum value of f. So we're going to look at what are the y values to finish the chart. So for 0, when I plug in 0 to the original function, I'm looking for what is the y value, right? An absolute max or min is talking about how high or low you're going on the y-axis, so it's represented by a y value. So here we are finding the y values by plugging in the x values to the function. So you have e to the 0, cosine of 0. We actually did this on a previous question. E to the 0 is 1. Cosine of 0, think of the coordinates there, and which one is the cosine? It's 1. So 1 times 1 is 1. There we go. Next is 2 pi. Plugging in 2 pi, you have e to the 2 pi, cosine of 2 pi. E to the 2 pi, I just have to leave because I don't have a calculator. 2 pi is here on the unit circle. It's a full revolution around. What is the cosine there? It is 1. So e to the 2 pi would be the output there. Next one is pi over 4. So e to the pi over 4 cosine pi over 4. Okay, so now we're moving away from that point, and we are looking at pi over 4. So pi over 4 is that middle branch. Maybe you know √2/2, √2/2. I will also remind you the trick there when we do 1, 2, 3, 1, 2, 3. All the denominators are 2. All the numerators have a square root, and we're looking at that middle branch. Pi over 4 is the middle branch of the unit circle. So cosine of pi over 4 is going to be that √2/2. So we have e to the pi over 4 times √2/2. By the way, if you feel like you need a lot of help on the unit circle, I just made a bunch of videos for the juniors introducing them to it. So you could feel free to ask me for those links. I could give you a version with questions embedded or without questions if you just want to watch the videos. Okay, very last one is 5 pi over 4. I love how they did this. So 5 pi over 4, we have e to the 5 pi over 4 and cosine of 5 pi over 4. So we already talked about this being 5 pi over 4. We also already discussed how it's negative root 2 over 2 and negative root 2 over 2. So the cosine is going to be, I'm going to just erase this so I have some space to finish this. The cosine is going to be the x value there. So you've got e to the 5 pi over 4, and then the cosine of 5 pi over 4 is the x value there, which is negative root 2 over 2. So I'm going to write e to the 5 pi over 4 times negative root 2 over 2. So that is the end of my chart. Then I just have to answer the question. So I don't have to justify. Well, it says justify, but the justification is my chart. But the question is, what is the absolute minimum? So what is the lowest y value? And we just have to point out which one it is. So I thought this was really neat how they did this. I'm going to just enter an extra page here, sorry. Take a look at that and look at the y values and which one is the smallest y value. We're looking for the minimum. And that would be right here. And I love how they did this because these numbers are so weird and we don't have a calculator. So you can see them wanting to make it a little bit easier on you and just making all of them positive except for one. So only one of them is negative, only one of the y values is negative. You would automatically know that is the smallest one. The other thing to pay attention to is when they're asking for the absolute minimum, are they wanting the x value or are they wanting the y value? Minimum is how low does something go on a graph, and that is represented by a y value. So let me copy from the question here. We are almost done. This is a really tough one. The absolute minimum of f on the interval 0 to 2 pi is, and then I'm going to put that y value, e to the 5 pi over 4 times negative root 2 over 2. If you wanted to write that nicer, you could put negative root 2 over 2 times e to the 5 pi over 4 and not have to put that multiplication dot. So absolute minimum of f on 0 to 2 pi is, and you're just giving that y value there. Let's look at this rubric. The first one is the first point is if you set the derivative to 0, and that was you finding a critical point. The second point is if you were able to find pi over 4 and 5 pi over 4 as candidates, if you knew to put those in your chart. And then the last point is if you were able to get the answer that the absolute minimum is this. Theirs looks a little bit different because they did not rationalize. So they used 1 over root 2, I guess negative 1 over root 2 as the x value on the unit circle as opposed to negative root 2 over 2, but it's the same thing. It's just ours was rationalized. I didn't write it like they wrote it because when we learned the unit circle, we just used root 2 over 2 and root 2 over 2. So I thought you would be way more familiar with that, and it's equivalent, so it doesn't matter. So that was in my opinion, pretty tough 3-point question. Hopefully that helped you understand it a little bit more. All right, great job.